Students, now today we are going to discuss about the Lorentz force, right? So the Lorentz force equation related to the combination of electro and magnetic field. Okay, electromagnetic field. If a particle of charge, suppose q, the charge q, moves with a velocity v in the presence of electric field as well as the magnetic field, it will experience a force, which is nothing but mechanical force, and the equation has been derived for your Lorentz force. Okay, so this is the force related to electromagnetism. Already have studied in your intermediate in the physics, right? So it will be developed whenever a charge q moves with a velocity in the presence of electric as well as a magnetic field only. Okay, it has been developed in the first 1889 earlies. Okay, so the name Lorentz. So the Lorentz force equation is nothing but it is related to charge. It has to move with a velocity v in the presence of electric field as well as the magnetic field. So Lorentz force equation consists of two terms. The first term because of the electric force q into E, and the second term because of the magnetic field q into v cross b. Okay, v is a velocity of the charge and b is the magnetic force or the magnetic field. Okay, so the Lorentz has born 18th July in 1853. Okay, so this is the data related and he belongs to Netherlands. Okay, this equation you have to remember: F is equals to q into E plus q into v cross b. So let us discuss some points related to Lorentz force. Suppose assume a charge resides at a point R and is moving at a velocity v. Okay, so the Lorentz force equation related to electric field as well as the magnetic field. Whenever both the fields are available, then only we have to focus and we are able to discuss about the Lorentz force law. Some mechanical force, some force is going to be developed whenever a charge carrying velocity with v. Whenever the charge moving with a velocity v in the presence of electric and magnetic field, then the force has to be developed. That force is given by q into E plus v cross b. Here E is the electric force, right? It may be represented by F suffix E, electric force. And remember, always the electric force is parallel to the velocity vector v. This electric force always parallel to the velocity vector. So whatever the magnetic force or the magnetic field, orthogonal or perpendicular. Okay, magnetic field or magnetic flux always orthogonal or perpendicular to the velocity vector. But what about the electric force? Always parallel to the velocity vector. So first, electric force or electric field. The electric field, right, maybe with the velocity direction or maybe opposite of the velocity direction. If suppose the electric force or the electric field with the velocity direction, then what about the net speed will increase, right? This may increase the speed as well as it means it will accelerate, right? It will accelerate the charge, means already it may have the kinetic energy. Each and every charge moving with a velocity means that should consist of some kinetic energy. So if suppose whatever the force you are applying in the same direction of the velocity, then the total force is going to be increasing, so the speed is going to be increased. So what about in the reverse direction? If suppose the applied force is reverse direction with respect to velocity, then it may be speed down or slow down the charge. Okay, so next, magnetic field, it is always orthogonal or perpendicular, so that's why we will write v cross b, right, into q. This is the term related to magnetic field or the magnetic flux density. And remember one thing, this magnetic flux density changes only the direction of velocity, not the magnitude. Okay, it will changes only the direction because always it is orthogonal or perpendicular to the velocity only, neither speed up or not slow down the charged particles, just it will change the direction only, and it cannot modify the kinetic energy also. But your electric field may vary kinetic energy of the charged particle. This Lorentz force equation you may apply in the CRT, cathode ray tube. Okay, in our monitors, TVs. Okay, there you are going to use the Lorentz force equation. So this is the electro gun waveform. Okay, CRT. Thank you.